Okay, Francis Jeffrey, everyone. This dude is the. It's Francis Jeffrey. He was the director of John Lilly's psychedelic flotation tank labs back in California. That's what I was really excited about, especially. But Francis, why don't you tell us a few words about yourself in other ways, okay? And then you can start. All right. So let's get a round of applause for you, Francis Jeffrey.
Thanks everyone for inviting me, and after like 2 or 3 years of absolutely dodging COVID, both Janine and I came down with the, they say the new milder form, which apparently was so contagious that all of our measures didn't do any good, and so we both started treatment on the same day as Joe Biden. And we're both completely over it, except, we're very tired, and it set back my preparations as well as the possibility of getting to Liverpool with Kevin, my fraternal Cal Bear buddy who's sitting over here on the side, by about 2 weeks. So I'm just rushing here, and the whole thing is kind of improvised. I emailed the syllabus, what would have been here last night. It's just a working draft. Which is an expanded outline of my abstract. So I'm going to be kind of using that as a kind of teleprompter, and I may ask Bruce or Randy and or Leon to read a few parts of it like we used to do, in the church. So responsive reading, and I've have some of the illustrations on paper back there, very old school, and a few props that I'm going to introduce to you before I start here. So, the reflections off my face are not some kind of war paint. It's some silicon, actually zinc and titanium oxide ultraviolet reflectants, because I just had some minor cryosurgery on my face as a result of a silly childhood spent on the beaches of Southern California before sunscreen was invented and we understood about hats. So this hat. So this is, someone give me a name for this, please. This hat needs a name. There'll be a bowler hat a little bit later on in the presentation, but what should we call this hat? Suggestion. Open to suggestions here. Anyone care to?
In the room?
Lampshade.
Lampshade.
Tinfoil.
Lampshade? Lampshade? Oh,
tinfoil.
I was kind of thinking of that great Theravada meditation master from Southeast Asia. What was his name? All right. We'll call this lampshade. Okay. And so I'll put lampshade aside now. This is my famous favorite ubiquitous demonstration object. So I guess we could call this the global brain. So as you can see, I've divided it on the Ecuador there, the equator. And so one imagines that the two sides of it are equal, except that we've marked them somewhat differently. So this would be, let's say, the North Pole. So it would be like this, But so since both sides are equal, I'm going to do it like this, so it's not a north-south problem. And then I've marked a couple regions here. These could be states or inner spaces, if you wish, in the laws of form interpreted as boundaries and containers. And the whole thing can be interpreted as what I call a boole note, B-O-O-L-E _ note, N-O-T-E, which is the way I developed of balancing one's perception and valuation of the two sides of any distinction when it's conceived again as some kind of boundary or container, not in its original pure form as just an indication. So if you have the equator, North Pole, South Pole, and initially, before we mark anything on it, they're equal, they're equivalent. And so one of the first thing one does in utilizing the boole notes, which makes this very explicit, the boole note represents and reminds us of both sides of the distinction. And we conventionally designate one of them as the inside, which would be like the inside of one of these bounded regions on a plane surface. Okay. What matters is it's the surface of topological genus 0, and the shape doesn't matter. And beyond that topological constraint, the conformation of the manifold doesn't matter, right? As long as we know the rules. So this is not like donut world. Okay. So once you have the bool note and the convention I adopted, the glyph for representing, thank you, Kevin, adjusting my video, can everyone hear me?
Yes.
Yeah. Good. For first stage in communication, does the signal get through? And, you know, communication is a very general term and concept because it starts with something could be an utterance or a gesture, a grunt, a word, a signal, a sign, a gesticulation of some kind is where it starts, and then we have refined it in our scientific and technological and mathematical thinking down to the point where Claude E. Shannon defined the bit, which has now become ubiquitous as a measure. It's properly a measure of data content or relative to time, bandwidth, data flow, but it's been misconceived as being actually information in a broader sense. And if you read the introduction by Weaver to their joint book, in which Shannon's original paper is the main contents, he makes it clear from the point of view of social science communication theory, of this distinction. But then not too much is has been done with that fact. I know some have, but it hasn't reached the surface. And so we have a so-called communication technology today, which is increasingly more and more communication in the simple sense, but less real communication. It is, as my dear old friend and creative collaborator Arthur C. Clarke said to us in Sri Lanka in May or June of 2000, he said, Francis, I predict we're going to see a lot more communication about a lot less in the future. So, and that is very much proven to be true. Now, making the situation even more complex, which is kind of the denouement of my presentation today, the misunderstanding and misuse of communication technology theoretically and in its hyper-commercialization that we have today, characterized by social media. The misuse of it has produced a state which I call distractopia, by analogy with Thomas More's classic. So in distractopia, most of the signals we receive, and even those we invite and patterns of communication we engage in, are about a very low real information value. So we have the bit per bit ratio, which may seem like a drastic idea, but it actually comes out of Shannon's original paper. He demonstrated that a bit of information in a communication stream on average has an actual information value that is somewhere between 0 bits and 1 bit. 1 bit being what you need to give a clear yes/no answer, for example, to a clear question in context between two conscious communicating entities. Another distinction which has been lost, you see, from the discussion of this. So we're getting very low quality bits, and that is absolutely contrary to human survival and progress, which is how I came to the final line in my abstract, questions of war and peace. One thing that Kevin, I think, Kevin, you're covering this from a handheld camera there?
Yes.
Okay, so if you bring up Kevin Ubila in his window, you can see some different angles on this, on the actual volume space we have here. So Kevin has been working for a couple of years. Hello, everybody there?
Yeah, we're gonna work on that. We're gonna do that so we can get the other angle.
Yeah, agree. Yes. Very good. So there you are, Kevin. Take a look at what's on the screen here. Come around and there you are. Oops, there you are. There you are. Okay, very good. See, so there we are. Okay. All right. So volume space, to understand volume space is very important. I relating to what Stefan Wolfram said yesterday, it's really created strictly by measurements, by connections between points. So I don't take physical space and time as physically real things. We have models intellectually in our own minds, in our own perception, in our internal reality that mirror our simulation of external reality and provide us with the impression or the experience of volume, space, and surface and objects in it. Objects being determined by interaction, things that resist, what you can do, add to them, modify them, move them. This defines objects very much in line with Jean Piaget and his colleagues in defining object relations as the basis of a developing child creating a normal kind of consciousness of things, persons, and spatial awareness. So I'm going to put down global brain for a moment. And here, this, what is the name for this guy? I guess we could call him Chubby Tube or something. So you can see he is also a genus zero topological surface, but he's in a different conformation. And we could just use, we could use a balloon or a piece of silly putty as long as it's unitary for this purpose. You know, I've marked on him an apparent distinction, again conceived as a element of boundary mathematics. There you are, that's that bright green line, and it's crossed by a white line and a red line, which is represent, they're present in a second dimension, or as G. Spencer Brown called it at the time we were working on the map theorem, a second degree expression. But if you turn it over, you see that the green line doesn't go all the way. So when you look at it like this, it looks like you have a distinction represented as a boundary, like we divided global brain there into north and south, or east and west hemispheres. But when you turn it over, you see it's not a complete distinction, whereas the red and white ones that are existing in a second degree, presumably in the same distinction dimensional space, are go all the way around, okay? And that turns out to be very important in relation to, what is the hat's name now?
Oh, lampshade.
Lampshade. So our friend Lampshade here could be seen as a globe or balloon that you compressed and folded in on itself. All right, and so if the side, which here we call the top of the hat, were, let's say, the northern hemisphere, and what's now inside was the southern hemisphere, and so we have a kind of higher degree dimensionality, which is a little different than the trinian, a very important mathematical object that I'll just call him G from now on, invented, introduced when he was working on the map theorem, which is what was going on at the time I met him. And so that produces, again, a very interesting category of mathematics. So I'll get to that. Does everyone have my syllabus that I mailed out last night?
We generally possess it virtually. And do you want us to pull it up so that we can refer to it, so that we can read from it?
If you can give it a screen, that would be good, because I haven't had time to print it out. I have it up on my screen here. Hi Jenny. Hi Janine.
Hi.
So,
I've got it up on my screen if you need me to share mine.
Okay, so
yeah, go ahead, Leon.
very good. Please do. There we go. So now, all right. So Francis Jeffrey, the phenomenology of 0 bits, which I think is a little bit. It's a bit of a pun, because we could talk about when there are no bits, which is where I start, and when we get to the end, we have bits that have a declining information value that are way below 1 bit per bit. Okay, and that's a ratio which I'll get to in the last part of it. So now I'm going to, since I mentioned the trinion, let's go back to the full camera view here. I'll just have a few words on the trinion to clarify that, because I know there's some interest and not everybody was in on the conversation around 1976 to 1982, which is the period when, let me see, 1972 I think was the Ohm conference. Is there anyone present who was actually at the Ohm conference at Esalen, early 70s?
Not me. And
Nope.
in this room, no.
No.
But what about virtually?
You've seen a video of it, maybe. Yeah.
Oh, yeah. Well, we've all seen photos and the transcripts.
Oh, great.
I'm all super keen on,
Great.
on all that. You got it memorized.
Great. I think Paul Herbert, who is the media archivist and recorder of Esalen Institute, who's since left the building, as we say, but I think he or someone else probably did a video, or at least an audio of it. So the I think it was in 1972. Is that correct?
Oh, it was 73, and interestingly, I got tapes back in like 2001 from Watts Tapes. That guy, and he explained to me that the sessions for days 1, 2, and I think 3, or everything except the last day is what we had, because the last day was lost in a fire. So I really wanted to hear George Spencer Brown and John Lilly have their back and forth, where John Lilly says to George Spencer Brown, so my last question, like, is it a way of traveling into other universes like I use at the Phenomenology Experimental Research Laboratory with Francis Jeffrey?
Very funny.
Well, he actually, that's not a quote, but he says something like that. And Spencer Brown famously, this is a quote, turns to him and says, "No, it's a way of coming back to this one," which I always thought was super cool.
Coming back to what?
To this one, to the indexical universe, to this universe of all the possible universes. When you're like going far out in the float tank, wherever whatever's going on in your internal reality, whatever brings you back to the, I guess, just general R of the first distinction.
And that's amazing. The bit about lost in a fire, that is truly, truly wild. Now, I know there's a lot of apocrypha circulating about that event and why Spencer Brown, didn't left at some point and so forth. And it actually turned out that A, he was bored, and B, he had to be back in England. So it really had nothing to do with the what some people said was an argument between him or personal animosities. That conference had most of the might call the mostly at that point West Coast luminaries, if you will. That's what they called it Ohm, AUM. That was Alan Watts' idea, which stood for Academy of Universal Masters. You get an idea, so of the quality of people, as well as their point of view in the 70s. And at that point, I had only met two. No, I'd only met. Actually, I had met none of the people at that point. So wild things happened in 1973, especially November, when I personally met Timothy Leary and John C. Lilly. The meeting with Timothy Leary was arranged at a point when he was a political prisoner in the United States. And so I spent like an hour with him, and under these bizarre conditions, and where I was actually, properly invited. I wasn't at the time locked up with him, and then we just hit it off. But I didn't see him again until probably 1979. And then also in November, shortly after that, it was a day that Alan Watts had died the night before. I went to a salon symposium at John Lilly's home in Malibu, and it was that same experience that we absolutely just hit it off. So we became lifelong friends. He was really a senior colleague, and eventually In 88 and 89, I wrote an authorized biography of him. That's John Lilly so far, that some of you might have. And there are some vignettes of some of these other people I referred to as the luminaries of the period. For example, Gregory Bateson and Heinz von Forster. And they were all great friends of one another. So it was an amazing, I'll call it the Lilly circle, maybe, in reference to the work of Professor Bruce Clark, who, as far as I can tell, is the preeminent scholar of these times and their relations.
Can I ask you? You just said Academy of Universal Masters, and I don't know if that, where it's published, it says American University of Masters, following Kurt von Meyer's records and Walter Barney's.
Okay, well that's probably right, Randy, because see, I wasn't there.
Well, I wondered though if there was different uses of the acronym back in the day at the time, before it got written down. I'm just curious about that kind of stuff.
I've even seen it referred to with the spelling Om, O-M, like the Sanskrit mantra syllables, disyllable in Sanskrit. Which is also it was a pun, so I'm not sure about that. So I didn't know any of those people. I was working at Cal Berkeley. Kevin as I mentioned is a brother Cal Bear, and although he's old enough to be my grandson actually, and I was also working at University of California, San Diego at La Jolla, and at Moffett Field. So it was a crazy time of flying and jumping around. And I was, by the end of 72, I had been given the use of the first great supercomputer that was called Iliac 4. And that was based at Moffett Field here in Silicon Valley on the San Francisco Bay. But it wasn't quite working until 73, so we had a simulation of the machine, which was the most advanced, and biggest, most powerful computer at that time, running on the most advanced and big and powerful computer that Burroughs Corporation made. Besides it, that was at the computer center, new computer center at UCSD, and this was a crazy.
I'm also the timekeeper. I just want to let you know, maybe like in five minutes.
Maybe we can wrap it up.
Because that way we can open up for questions and answers in about 5 minutes. Yeah.
Okay, so everybody has access to the syllabus. So I'm just going to read the first and the last paragraph into the video record, and then post symposium I'm going to add. I'm going to clean it up a bit and add the illustrations and the references, which are extensive, of course. So is Bruce there? I think Bruce has some of the graphics I wanted to put up, which are included in the syllabus. There's I guess we have the PDF version on the screen. So there's an illustration in there by Gordon Pask, which is called "The Man in the Bowler Hat." Ah, there you go.
Oh, that's good.
Excellent.
There it is.
Okay, so what you have here, which is kind of central to everything, is you have a depiction. This is something Heinz von Forster loved to show. This is from the late 1970s, I think, but it was drawn by Gordon Pask, another great genius.
Actually, Francis, it was already there in 1960. It was on self-organizing systems and their environments. There was a whole discussion of the man with the bowler hat.
So thank you. I suspected as much. So it's the idea is that the brain, human brain, and other similar brains is a medium in which are created simulations or models of internal and external realities. John Lilly's term IR and ER, which is different than inner and outer relative to the body envelope. But it interacts with it in a very interesting way, which this kind of illustrates. So the idea is in the brain then is this kind of modeling medium, and I absolutely object to any description of the brain as being any kind of computer, because it's absolutely nothing of the kind. Okay, the computer, the digital computer, is an extraction using logic and mathematics, a very small part of what we know the brain can do. And Warren S. McCulloch, in that great paper and several others that I cited, demonstrated, particularly his work with Walter Pitts at MIT, they demonstrated that a system made of neurons, as they were understood at the time, could be organized to do things we consider to be logic and arithmetic. And that was an important philosophical point, but the brain doesn't do them anything like the invention of the digital computer. That's a very important distinction, which I'll cover for a minute. So the man in the bowler, let's go back to the bowler hat if we could.
Okay, and this is now the 2-minute warning.
You mean we've actually used up 40 minutes here?
Well, we're leaving some of it for questions and answers, so we can open it up for some dialogue. And I know.
Oh well, you just have to let me go on, because you've already had some dialogue.
Another 5.
And there's also a discussion period following, and actually this in some ways integrates all the previous presentations. So
right, that's true.
I think we can tag in there. So the man with the bowler hat indicates you have an organism, a human being in this case, and in the brain he has model simulations of internal and external realities, including other people, including himself. And you see the model of himself in his brain is the same thing. So it's an inward recursion of models. And we think in neurophysiology that this is what drove the so-called evolution of the human brain, and a few other organisms such as dolphins have very disproportionately large brains to their bodies. It was driven by the need to model one another in this very complex way, to simulate or model your expectations about other people's expectations, motives, plans, and the meaning of their communications, which is extremely non-trivial and depends on context, and I claim on another factor, which I call communion, in a function which is outlined at the bottom of the syllabus. So if you look at it this way, what is represented in the brain is called models and simulations of internal and external reality are experiences. It's what we experienced. And you see, that's the mystery of life. How do we have experiences that have all of these fascinating characteristics, ranging from formal characteristics like pictures and geometry and our sense of volume space with all the perceived surfaces and boundaries in the volume space, which is what I call the bubble of perception. That's an exercise which I at one point propagated to raise awareness of this. But also, how could the brain, being constructed the way we now know it is, which is of course imperfect but increasingly detailed, and gets us into what I call quantum neurophysiology, where Penrose and Hameroff, I think, is a leading candidate for a comprehensive theory that's developing. How can the brain, made out of all this physical stuff, actually do that, right? How can it host experiences, whether they're internal reality or external reality? And the interesting point here, just as physics is known to be based on measurement, science more generally on observation, but in physics they're very specific, especially quantum theory, call it measurements. Einstein was very clear with his measuring stick, which I have here, which he calls S, which corresponds to the successor element in the arithmetic of whole numbers, right? So here's the stick, that's 1 foot, okay? And so distance is defined by 2 objects, which could be seen as points or as quantum particles, and they have between them always a gravitational relationship. Every pair of atomic mass units, for example, every proton and neutron in the world, in your body, in the entire universe, is connected to every other one in your body, in the earth, and in the entire universe by a line of relationship, all of which we can conceptually graph, which again relates to Stefan Wolfram's description of reality yesterday. and the distances are measured using the measuring stick of some kind. That is, by always comparing it and then turning it end to end. And time, as Einstein said, is what clocks say, which can be in different places, in different accelerated and relatively non-accelerated frames of reference. And as Stephen Wolfram pointed out yesterday, time is a succession of events which are usually related to irreversible computations and transitions, which essentially is the problem. Now let's see. Let's put up the Tibetan diagram, if you would. Oh, excellent. So this is a fairly ancient symbol from Tibetan and other Buddhist and yogic Vajrayana or tantric meditation practice, which is something we were all into back then, most of the people in the group in the 1970s. And so I have a version here on the screen. So let's go back to my live video. So bring up my live video here as the main thing, please. So can everyone see my drawing board?
Yeah.
Okay.
Yes.
Yes?
Yes.
Very good. Okay, so here I've just done a very glyphic depiction of it. And so it can be seen as some kind of higher degree, in Spencer Brown's terms, superposition of distinctions of different kinds. So there's an apparent distinction, a polarity here, and it's crossed with another one. And this turns out to be in the original traditional form a very powerful symbol for what is called the Vajra-like samadhi in the classic literature. I read quite a bit about this at the time by books by Chögyam Trungpa. Again, everyone very connected in this time. So things made more sense. Now, this is the Trinian. Is that kind of marginally visible there? I think, does Kevin have a better view of it? Apologies, I didn't really prepare.
No, it's great. Yeah, we see it really clear.
Okay, so this shows, this is a, I'm going to go first to the Trinian. Got away from me here. Where did my other Trinian go? It's not there. Well, stuff just flies away. Okay, I thought I had another one on the board here. All right, so this is a form of Trinian that corresponds to another prop has to come in here. All right, here we are. All right, if back to my my home screen, if you will.
Okay.
There we go. Good, home screen. Okay, so what I've done here, this is a tripod. It's a camera tripod, but I've converted into a tetrahedron, you see? With this being here the apex. If you think of it as a pyramid there, sitting on a surface. All right, pyramid surface. And now, so you have 4 vertices, which are points, okay, and then you have 6 line segments. And so that's sufficient to fully and directly connect, in a sense of a graph, all the nodes using links, okay. And so you have a total of 4 faces, hence tetrahedron, 6 links and nodes. And those could be corresponded to the spaces in a map, the regions in a map. So this corresponds very closely to the proof of the 4-color map theorem. Now, imagine at the base of this, that is the 3 lines and points that I've outlined in Chartreuse, are sitting on a window or a mirror, you see. You can look at it this way. And now there's, what happens if you add one more point? Now, well, first of all, you can see you could collapse the whole thing like this into the plane So this diagram could be represented simply as a graph in the plane, and the graph is also, it could also be, the graph could be seen as a map. So see, every map has a graph, and every graph has a map, and there's a lot of theorems to do with this that Francisco Varela, another great mathematician who's also left the building, named Jay Guggenheim at UCSD, worked out it, and Heitz and I were advancing that field around 1979 after he settled out here on the beach side of the mountains opposite Stanford. So that can be collapsed into the plane. It can be flat. And so it characterizes everything that can be represented on a plane surface of genus 0. But if you go into three-dimensional space, or volume space, let's call it, without biasing how many dimensions it really has, because I actually believe it doesn't have any, but until you conceive it, you see it, or observe it, we could add one more point, and that's this little chartreuse button here, and I'm going to put the point in the center of the tetrahedron. Okay, so now I've added a fifth node. Okay, and now if we connect that node to, it's already connected to the apex of the pyramid here, but if we connect it to the other 3 points, all right, we have a figure which cannot be collapsed into the plane without crossing lines in the plane. Everyone with me there? So now I'm going to put that down. I'm going to put that last point, there it is, down on the plane, and you can see how it's impossible, no matter how you turn this, to collapse the whole thing again like this without lines crossing, which is more or less equivalent to the proof of the four-color, or at least demonstration of the four-color theorem, which is difficult to deal with because of the odd terms in which it's stated. It really should be stated in terms of graph theory, and of course many people have done this. So, so that's very important because it illustrates the idea that a certain degree of complexity in a map or a graph cannot be represented on a plane. And of course, in our electronic technology, we use the equivalent of printed circuit boards. And so we have to put bridges between points so that the lines don't cross and short circuit. And that's what in G. Spencer Brown's laws of form he describes as subversions, right? Where you have a tunnel under or above the boundary map or the LOF lineal expression, right? Or so it could be a feedback, a feed forward. And I know there were some members of the group who have worked that out in great detail from Spencer. Yes?
Yeah, so I was thinking we can do like a transition to Q&A. So and highlighting like different areas for further research, you know. I don't know. Let's do you want to conclude like or like, I mean, do you want this to be like a little transition kind of thing, and then we'll open it up, we'll have like a dialogical.
Yeah, so okay, very good. So bring up the expression in the syllabus of my formula. It says there's an I, a double dotted I equals F of 3 parameters, H, and then there's 2 Hebrew C's. Okay. There we go. If everyone could see this. So when I thought very deeply about Shannon's communication theory, again, in relation to a bit or 0 bits. And I conclude that in real communication, which is between minds, that's John Lilly's definition, as a variation on Shannon's, communication is between minds. And that's also the title of the book that I'm struggling to wrap up here. So I use the symbol I double dotted to mean real information in units that Shannon defined, okay? So we're talking now about bits per bit. And so the value of a bit, which the real value of a bit as real information, as communication between minds, that's the double dotted I, is equal to a complicated function of H, which is Shannon's measure, originally called entropy. And that's the amount of information scored in bits by his definition, okay? And the second parameter, so I've used a backwards Hebrew C, that's a, or kaf, to make it very mystical, that's context. And context can be pretty well described as what Stefan Wolfram was giving us yesterday, which is graphs of the structure and then the progression of things, okay? And pieces of graphs can, as he described, be disconnected, moved around, and reconnected in this configuration graph space, all right? And I call that...
Do you want to...
Let me finish here, Randy.
Yeah, sure. Okay, go ahead.
I'm wrapping up here.
Okay, cool.
So, yes, good. We've got the diagram at the bottom. Okay, so it's finally... and that's in the, if you read my July 4, 2000 US patent, in which an actual working technology to do this very effectively was disclosed, okay, 5 years after we had it working. In there, it describes the clump and the clumplet. So I call it a clumplet, which is a packet of information as a little network that can be taken off, reattached somewhere else, duplicated, spread around, propagated, modified, and so forth. Now, we get down, the last element is, which represented here in a sense by the colored area in my coloring of Shannon's rainbow, which is also inspired by Thomas Pynchon's gravity rainbow bit in relation to war and peace. So this is Shannon's parabola, which shows you that if you imagine a bit as a coin, if you toss the coin, if the probability of either heads or tails is equal, okay, then you have 1 bit per bit, 1 bit per toss. And that's based not only upon the source, in that case, a sequence of people tossing coins, let's say, and then recording the results, but it's also based on your expectations. And that's why the formula, my I equals F, is rather complicated, which, of course, obviously we don't have time, and I'm not quite, it's complicated because the 3 terms are not independent. So this needs to be factored out into a full and complete expression, and we still may have to do some research to answer some questions, which is in part what we were doing with the human-dolphin communication way back when. So when the level of the, you see at the center of the graph, the parabola at the top of the graph has a value of 1. That's 1 bit per bit. But as the probability of the 2 sides of the coin becomes biased, then the value drops according to the line of the parabola, and it approaches 0. And my point in that formula with I dotted I equals F is that you can see that at the boundary conditions, if there is no context or too much context, the value bit per bit also approaches 0. And if there is no communion or too much communion, then the value also approaches 0. So there's some optimum combination of data rate or data content in Shannon's measure, communion and communication. And what has been lost in our modern so-called communication in our social media and so on is that the context is often ignored, even though we can very nicely represent it. Okay, and it must be shared among the people, the beings at both ends of the communication channel to get the maximum value. Must have the same context or approximately the same context. But what's been totally wiped out and degraded and left to the domain of mystical religion is communion. And when communion is either too much or too little, the value of the communication drops to 0, as well as the actual experience we have of whatever it is. So this is very important, because when the value of the bit becomes close to 0, the resulting bit, the double-dotted I, then the world becomes very dicey and precarious as it is today. You know, we have a war like 100 years ago in the middle of Europe. I mean, who could imagine that, right? 2 years ago. And we have this conflict on the other side of the continent developing. And it's because of this neglect of these other 2-dimensional parameters of real communication. So I just have to show you one more thing. And that is, I'm going back to my whiteboard, my physical whiteboard. Okay, can everyone see that? Okay, good. I don't know if that's, is that well lighted, badly lighted? Let me turn on the lights.
So let's up with it in less than just like a minute or two, and then we'll clap and then
there, the light is on. Okay, there.
We have ideas to talk to you about.
So, all right, there it is. So what I've illustrated here is we have two organisms, two beings, and they have many levels of organizational scale. Up here, it's the whole organisms as a whole who have a body envelope, a boundary, like the man with the bowler hat that is perceived, and they are exchanging messages. It might be human language, could be other things. Okay, and at the bottom of this, we have the most minute scale of things like atoms, elementary particles, quarks, and so on, out of which all this is built. And there are intermediate levels such as tissue and organ systems, different kinds of cells, right? Subcellular organelles, macromolecules, which can be messengers of communication, as I described in relation to Bernard Katz and Candace Pert, a couple of people I got to work with that are in the syllabus. And so the horizontal dimension would be many of these columns, different beings, and over here we have a digital computer or a system based on discrete algorithmic programming, which has now joined this game as this other column. So we certainly know that communication exists with varying degrees of quality up to very good among two organisms at the level of their physical boundaries and interpersonal boundaries. And we also know that communion exists in the sense of we can have pairs of elementary particles, for example, a Pauli pair of electrons after Wolfgang Pauli's paradigm, which are spin correlated, one spin up, one down. They're prepared this way, and then they move apart in space. And the correlation is maintained. That's what's been called quantum entanglement. And so that would be until there's some major disruption of one of them occurs, that could be viewed as a 100% perfect communion, or a communion value of 1 in our equation, you see? So that exists there, this exists here, and the thesis is that, which was also Schrödinger's view as far as I can decipher it, the thesis is that our ability to both experience and to have creative consciousness, creative intelligence, is founded on what is actually not only the horizontal-wise, circular and back and forth relation between these entities in ourselves and between ourselves and others, but it's also founded upon actual communication, interaction, relationship, truly integration from our surface level down to what we think we're made out of.
Okay, I think
that's it.
Thank you.
So Francis, now we have this panel section, and honestly, I don't remember what it was about exactly. I did know that at first we had really hoped to do like a workshop where you could kind of illustrate what it was like. The labs, right, Perk and Float, back in the day, the work that was done implementing laws of form, in particular, in the tank, and and that Spencer Brown was there. Maybe just a few historical facts about when Spencer Brown was there, and maybe even like what you and John Lilly had in mind with this phenomenology of nothing that you've published on about it before, and and the methods that outlined in the center of the cyclone, the dyadic cyclone, for traversing whatever phase space or possible universes in the tank, and of course we all know fascinating substances were employed to facilitate imagination, in this float tank first personal scientific environment, and so I'm just curious about some historical facts, about, in particular about Spencer Brown, about laws of form, in that environment, or even like the later work with NASA and DARPA. If you could reveal any kind of top secret information, that would be great.
Well, with the NASA and DARPA, I think it was mostly the work with DARPA. I was interested in the iliac force computer because I realized that actually constructing network graph models, we called them cognitive or semantic networks. This is like around 1970. and we had little dinky computers, and we could make these models on the computer using the crummy software that was available. Sometimes we had to hand code it in machine language, But so I thought and wrote about it and said that to really do these models properly, like the kind of detail like Stefan Wolfram was showing us on his screens yesterday, and then actually make them dynamic so we can demonstrate that they actually work, and to some extent that they would emulate human perception, cognition, and so on. In other words, the quest for so-called artificial intelligence. I realized it required massively parallel processing. And so that caught someone's attention because NASA and DARPA had just bankrolled this supercomputer. It was very expensive. It occupied, the size of, I don't know, what do you call it, a Safeway store? What do you have in England? A Spencer's or something, right? So it's like a supermarket-sized bunker under the airstrip in Moffett Field, all extremely air-conditioned and it was using megawatts of power.
Okay, so I wonder.
You understand?
Yeah.
We had this huge computer, and the problem was. And so that's basically why I was attracted to and hired there. But what they actually had me doing was their priority, which was the simulation of nuclear weapons tests and explosions. So that was interesting. It was a whole education area. I wasn't too versed in, which is the physics of nuclear weapons. It is extremely fascinating, the methods of Monte Carlo methods of John von Neumann and so forth. So we were programming this. I found out years later, because they never told us what they were doing with this. I found out years later that it was crucial in securing a succession of nuclear weapons test bans, because we had demonstrated well enough that you never needed to test another nuclear weapon because you could just simulate them from the data you already had, and you could project the results in an explosion underground, underwater, in the air, or in space, and what effect it would have on, let's say, a city.
Okay, so Francis, that's super fascinating. I just want to ask, right here, just me asking you about laws of form, about Spencer Brown, and in particular about the void method, right? Lilly calls it the void method. So I want to know what's the void method, and then we can open up to questions based on that.
So what we tried to, we built very good sensory isolation tanks, and there probably ones that in some respects are better today in these street corner float salons, which are I don't know, they're not quite as numerous as storefront yoga ashrams in America, but they're around, and then somebody has some very good isolation tanks. So we had some very good and then some less perfect isolation tanks, and I designed what I thought was an absolutely perfect one, or as close as we could get, that would provide no stimulation, no irritation, no interaction whatsoever, and so you could immerse yourself in the fluid.
Yeah.
And I wasn't using Epsom salt. I embedded a fluid, a whole system, so you could immerse yourself in there for very long periods of time, and basically you could do mathematics or yoga or creative thought, free association. You could lapse into the kind of vivid dreams that John described and so forth. Now then, as I said, in '73, I met first John Lilly, that was in November, and then everybody in that circle. I also was guided by my guru at Berkeley, that was Professor Lawrence W. Stark, S-T-A-R-K, another great, memorable Calvert genius. He introduced me to Heinz von Forster and to Roland Fisher. He said were two of the most intelligent people he had ever met and worked with that were still alive. He'd already introduced me to Bernard Katz, who came over to Berkeley right after he got his Nobel Prize.
Okay, and can I just ask you to jump to George Spencer Brown? Any historical details?
Well, if you stop interrupting, Randy,
I know, but we need to open it up to the panel.
So I found around that same time, I found Laws of Form in my favorite bookstore and started reading it. Okay, around the same time I met Lilly. Then from Lilly I learned about the Ohm conference. And then, eventually in '76, I called G up on the phone and got him immediately. And again, we hit it off like that, bang. And I said, well, why don't you come over here again and teach? And so that was maybe number 4 or 5 in the Float Perk series of seminars that was conducted in Big Sur in 1977, but in that intervening period between 76 and 77, when I was talking to him on the phone and corresponding to some amount, and before meeting him physically at that first symposium, and he was coaching me to integrate what I call the meditation of the Vajra like Samadhi and some related Buddhist approaches, to integrate that into the float tank, rather than the many other things that could be done. And so that led to this crystallizing experience, which I recorded in my diary on the 10th of November 1976, in which I did the man in the bowler hat trick, you see, and the whole perception condensed into an absolute stasis and equilibrium around nothing. Okay, but it's not the void of annihilation, the empty. It's not the blankness people imagine, but it's the absence of a distinction between determinate and indeterminate. And in it, the geometry of everything, internal realities, external realities, are stabilized and frozen into this crystalline state, which is what the Vajra actually refers to.
Right.
It's the jewel in the lotus, and it was on the basis of that. That is what I call the culmination of the void method. And many creative ideas and projects then stem from that.
That's beautiful. I really appreciate that. That crystal was what I was looking for.
Om Mani Padme Hum. I also had at Berkeley, circa 1970, I had two Tibetan Buddhist lamas that I could study with, and I was also exposed to Schrödinger, who was described as the 44th patriarch of Zen Chan in the Chinese Chan tradition. He's a very big deal. He's left the building, but see, he has a huge following here in Taiwan.
Right. Well, so I think that's sufficient. I just wanted to get the historical facts out, But I just want to now open it up for further discussion, since now we're in a segment called panel discussion. Okay, so was that a hand, Fred? Oh, okay. Let me just open it up a little bit. Okay? Yeah, go ahead.
So, very interesting talk. As perhaps as an experimental exercise in thinking, to bring us back to the man in the hat, the bowler hat, past man in the bowler hat, you were describing the way that models of models are what drove the evolution of the human and perhaps the dolphin brain. Here's my question.
Yes.
What would halting the evolution of the human dolphin brain look like? What would halting look like?
We might be there, because it could be that a survival critical mistake is made, and that's why I'm so concerned about the degradation of the bit value, right? And the loss of verifiability, the loss of veridical information.
Okay, great. And Alexander has a question now.
Yes, thank you very much for the presentation. It was very interesting for me. But can you repeat the explanation of commune?
Alexander, was yours a highly mathematical, physical presentation that preceded Wolfram yesterday?
No, it was the day. No, I'm not that much mathematical.
What was your topic? What was your topic on the?
My topic was on architecture. In between.
Oh yes, architecture. Okay, there was another person I had.
It was today. It was today afternoon.
Yeah, so I'm like 2 weeks behind here, so I still have to I scanned. I need to thoroughly read everyone's presented paper.
Don't worry. I was just asking about what you mentioned about commune.
Diego,
Can you
Ciao, Diego.
repeat that, please?
Ciao.
That was absolutely brilliant. Bene, grazie. That was absolutely brilliant as a lead into what Stefan Wolfram said, right? Which basically led into, I think, what I said first. So now the question was, where were we?
Alexander had a question.
Repeat, Alexander, please.
The question of how can you repeat the explanation of commune, the concept of commune.
Yeah,
Not communication, communion, sorry, not communion.
Communion. Well, it's a very old idea, but we can actually reformulate it, measure it, and prove it. So what I said, the difference between internal and external realities, they're equally real in the sense that they're simulations that run mostly or apparently in our brain, but not exclusively so. And they give us our experiences. So it's the capacity for experience. So I've come to the conclusion that the capacity for experience is not only what we talk about, our experiences more than anything else, you see. So it's what we communicate about. It's also what we communicate. It has different metrics. Okay, so internal reality, the metric, external reality, the metrics are what you can measure with physics. And if your internal simulation model of external reality is a pretty goodness of fit, we call that good science or good relationships or good business, or you don't trip and fall over and smash your head. So that's goodness of fit. So that's good. The internal reality, it's all the same thing. It's experiences, and they often correspond. They just seem just like external reality experiences. Likewise, there are simulations or models that are running mostly in the brain. An example of that would be sleep. You're sleeping and dreaming. You can have dreams that are I've had double lucid, triple lucid dreams in which some people in different places have actually spoken to me. Okay, I'll go into another time. Okay, and then I verified afterwards that it was actual information that I got. It was real. Okay, it's not an illusion. But the metrics of the inner realities have to do with fluidity and the limits of what you can do. For example, you can fly, for instance, right? But sometimes, and even in a lucid dream, you can't control what happens. So those are metrics. So these two inner and outer realities are both metrical in the sense they can be measured. So they're equally valid topics of scientific inquiry. And the profound isolation is extremely under conditions of zero stress and zero interaction. It's an extremely valuable tool for studying experience, and that's the phenomenology of it. We have to relate that to the epistemology, which is a classical study of what we can know, how we know it, and how we know that what we think we know is in some way critical or accurate.
There's another question here.
An observation about Byron.
Who's that?
The tetrahedron can be turned inside out, outside in. Can be projected, but it can be inverted. But it's inside turns outside and vice versa.
Yes, and that's the diagram I put up of the trinion. Could you go pull my trinion picture back up, Kevin, or somebody? Well, hi, welcome. The trinion, it's the two L-shaped things overlapping. Yeah.
Can you please post it for everyone?
Huh?
Can you please post your talk,
yes,
for everyone? Okay, it's been filmed.
Yeah, it'll be exactly film, and also the syllabus. I invite whoever has a copy of that to share it around. It's a more expanded outline based on my abstract, and I'm going to then publish that in a couple of days with the references, which are extensive, and including references to Professor Bruce Clark. Very significant in the evolution of my thinking since we met a couple of years ago.
Very good. We have another question from inside the room here. Here you go. Here's another question. Okay, here you go. Everyone, please be quiet and listen. Okay. Here, Lori, go ahead and ask your question.
Somebody put up the symbol is like somebody.
James, I was going to ask that there was a early neuroscientist, or perhaps predecessor to neuroscience, but he invented something called progressive and differential relaxation, and he would measure the stress energy or the electromagnetic activations in muscles, and he noticed that there would be altered states of consciousness when particular muscle sets would become completely relaxed or approach what he called a zero action potential. So the extraocular muscles and the laryngeal muscles, which relate to how we kind of focus the world and how we mentate in a verbal form. And so I'm wondering if the flotation tank experiments and different forms of meditative absorption relate through this relaxation of perhaps there's a muscular component to localization or reification as a individual experience.
Absolutely. No, that's absolutely true. But that's not something that Lilly and I were studying. But that's been extensively studied by others since. It is absolutely true. But that the flotation or void method, which is combining some meditational discipline with the flotation tank, I call it profound isolation environment. It involves decoupling from physical interaction and combining extreme relaxation, and that's extremely important in being conducive to the practice of these higher yogas, whether they're described as Patanjali or so. Yes.
Just a one-sentence yoga, because just because you were talking about lucid dreams, and so in Vajrayana Buddhism and Dzogchen, they use the dream.
Which one?
Vajrayana, and in Dzogchen particularly, in Vajrayana Buddhism, they use the dream time and lucid dreaming to have interactions with teachers that are not necessarily proximate to them, or to explore the lessening of limitations, as you spoke about flying, or playing with the rules of the dream as a game.
Yeah. So, I want to thank you, Francis. Okay, everyone thank Francis.
Okay,